Today we're going to look at multi-step equations, and I don't think multi-step equations are any harder than two-step equations, mainly because if you remember from two-step equations we used reverse Pemdas, and if you kind of keep that in your mind, it makes every single equation the same kind of thing to solve. So again, we're going to use reverse Pemdas, and I'm going to look what operation I have first. Well, if we're going the opposite way up, we're not going to do the stuff in parentheses, so the first thing we have is a multiplication and division, which is this 4 right here. Well, since that's multiplication, I'm going to undo that by dividing both sides by 4. And that's going to give me 3x plus 5, which is equal to 8. Now again, the parentheses kind of drop, so I look again. And now I do have an adding and subtracting one, which is this 5 right here. So we are going to subtract 5 from both sides and get 3x equals 3. And then we're going to do our very last step, which is divide by 3 and divide by 3, and finally get that x is equal to 1. So again, it kind of looks at the beginning to be very complicated, but if we use our reverse Pemdas orders, it doesn't become too difficult to solve. Let's try another one. Okay, so in this problem, again, we have a lot of different steps, so we want to use reverse Pemdas. And when I look at this, I go, okay, when we're going up this way, it kind of looks like subtractions first, but again, if you remember from my other video, when we have a long division bar, it's kind of like we have implied parentheses. So it's kind of like the parentheses are implied there. So the first operation we do have to deal with then is division. And to undo that, we're going to times by 5 on each side. That is going to give me 4x minus 12 is equal to 100. We're then going to add 12 to both sides, because that's the next operation that comes up. That is going to give me 4x equals 112. And then we'll divide by 4. And I don't know what that is, so we are just going to leave it as that fraction. Anytime that you can't divide a number like 112 over 4, you can just leave it as a fraction. We can get a decimal approximation if we throw it up on our calculator here, so let's just see. Oh, I guess it does become a nice number. So that would become 28. There we go. Let's try another one. Okay, again, we have a very long problem, so we want to use reverse Pemdas to figure out what operations to do first. And since we're going this way, when I look across this, I see a subtraction that's outside the parentheses, so that would be first. So we're going to add 6 to both sides. I'm going to go 2, 3x plus 4 is equal to 16. The next operation we get is multiplication and division, because this is really a multiplication there. So we're going to divide each side by 2. That's going to end up giving me, because these will cancel, we'll get 3x plus 4 is equal to 8. The next thing we'll do is we have a addition and subtraction, so we're going to minus by 4, which will give me 3x equals 4. And then we're going to divide both sides by 3. And I know this doesn't divide nicely, so let's just leave it as this improper fraction. Again, if you want to get a decimal approximation, you could take the calculator, and it's 1.3 repeating. So it's probably just nicer to leave it like that. That's essentially all I have for the multi-step equations. It's very, very similar to what we've been doing. The biggest thing that you need to remember as you go through these problems is kind of use this reverse Pemdas so that you know which order to go. Because if you kind of go outside this order, it's like our order of operations. If we go outside that order, we're going to get ambiguous answers. Like we'll get 2 different answers and we'll have that argument which one's right. So if you follow this reverse order, it will set you up for success.